Now next problem. Okay, there is dot dot. Okay, it is dot dot, and this is equal to 2 by 3 log 2 to the base. Okay. Now follow the next problem. Is what? If a plus b plus c is equal to 0, using the expansion of the type log 1 minus alpha x minus alpha x minus alpha square x square by 2 minus alpha q x cube by 3. Okay, then prove that a to the 5, b to the 5, c to the power 5 by 5 is equal to a to the power 3, b to the power 3, c to the power 3 by 3 into a square, b square, c square by 2. Okay, and this is the JEE question in 95. Okay, and now see for that the solution. A plus b plus c is equal to 0. So you can write here a cube, b cube, c cube, and c cube minus thrice abc. The factor is here a plus b plus c, and another is here a square, b square, c square minus ab minus bc minus ca, and this is 0. Okay, so this is 0. So you can write here a cube, b cube, and CQ is equal to thrice ABC. Okay, again now a plus b plus c is equal to 0. Implies that a square, b square, c square plus twice ab, bc and ca equal to 0. So therefore write here ab, bc plus ca is equal to half of within the bracket a square plus b square plus c square is this. Okay, and now the question is that we have to show a to the power 5, b to the power 5, c to the power 5 is and now for here is ABC. So we can write here the formula of that log of 1 minus ax is here minus ax minus ax square. Okay, a square x square by 2, and this is minus aq x cube by 3. Okay, like that, and again log of 1 minus bx minus b square x square by 2 minus b cube x cube by 3 minus b4 x square 4 by 4 minus b square 5 x square 5 by 5. Okay, or same as like that. Also you can write here a to the power 4 x to the power 4 by 4 a to the power 5 b to the x to the power 5 by 5. Okay, then infinity and then it is infinity. And also same as log 1 minus cx minus cx. We write here cx c square x square by 2. Okay, minus c to the 5 x to the 5 by 5. Okay, and adding this two, this is 1, this is 2, and this is 3 here. adding these three, adding 1, 2 and 3, then we get here 1 minus x, 1 minus bx and 1 minus cx. Okay, if we added this, then we get here a plus b plus c x, and we get here that is x square by 2, a square plus b square plus c square, this is by 2, okay, and same as aq, bq, cq by 3 and x cube, okay. Now see, and this is here a to the power 4, b to the power 4, c to the power 4 by 4 into x to the power 4, same as a to the power 5, b to the power 5, c to the power 5 by 5 into x to the power 5 there, okay. And now multiply this, you get here log of x into within the bracket, okay. Then again you can write like here plus x square ab, bc and ca, and minus abc and x cube, okay, and minus a plus b plus c x and dot dot minus a to the power 5, b to the power 5 and c to the power 5 by 5 and x to the power 5 and dot dot, okay. And from now log of a plus b plus c here is 0, it is given, so it is eliminated. Now in place of x square, in place of that we can write here this is what? This is minus half. So minus half x square within the bracket a square, b square and c square. Okay, now ABC, and that is ABC. This is minus here, minus AQ, BQ, CQ by 3 into x cube. Okay, same as a plus b plus c x and dot dot minus a to the power 5, b to the power 5, c to the power 5 by 5 into x to the power 5. Okay, and now it is take a common here, like within the second bracket we get this. Okay, and if we expand by this, then what we get here? So that is, this is a whole x. So half x square within the bracket a square plus b square plus c square, and this is minus x. Okay, this is 1/3 AQ, BQ, CQ by 3 and x cube. Okay, this is, and this after minus this is square by 2. This is okay, and this is by 2. So this is half here, and this whole thing is square. So 1 by 2 x square, a square, b square, c square. Okay, AQ, BQ, CQ by 3 and x to the power 2, and this is whole square and dot dot dot. Okay, then after this is equal to, on the right hand side here, x in the a plus b plus c and minus dot dot. Okay, minus dot dot, and this is my x to the power 5 here, and coefficient is a to the power 5, b to the power 5, c to the power 5 by 5. Okay, minus dot dot. So compare comparing both sides the coefficient of x to the power 5. Okay, comparing both sides with the coefficient of x to the power 5. Comparing the coefficient of x to the power 5 on both sides. Then, okay, so that is here. If we want to find x to the power 5, if we expand this, see here, after that this would be get here twice a b. This is x to the power 5. Okay, but after the expand cube, whole cube, there is nothing we get here x to the power 5. Okay, only in that part we get the coefficient of x to the power 5, and that is twice a b. This is a and b whole square. Then we get here twice a b. So the power of x to the 2 and x to the 3, the power we added, then we get here x to the 5. So that is the coefficient here with minus half, and this is 2 into like a b, this is half a square, b square, c square, and this also 1/3 of that. Okay, this is here 1/3 of a cube, b cube, and c cube. Okay, and this is the coefficient of on the left hand side of x to the power 5. After that, on the right hand side is this, and that is equal to, this is minus a to the power 5, b to the power 5, and c to the power 5 by 5. Okay, so see, these two are cancelled and minus minus are cancelled. So therefore, a to the power square, b to the power square, c to the power square by 2 into a to the power 3, b to the power 3, c to the power 3 by 3, and a to the power 5, b to the power 5, and c to the power 5 by 5. So this is your proof. Okay, very interesting question. See carefully. Now next question. This is a very interesting question. The next question is, see, in 1985. And next question is that if y is equal to x plus x square by 2, x cube by 3, dot 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 dot, then find x in subject of y. Okay, then find x in subject of y. So this is your question. We have to find x in subject of y. So see, if we minus by multiply by minus, then you get here. So this is the logarithm series. Okay, so minus y, we get here log to the base e here 1 minus x. Okay, taking anti-log, 1 minus x is equal to e to the power minus y. So after that, the series of this series here is 1 minus y by factorial 1 plus y square by factorial 2 minus y cube by factorial 3. Okay, and eliminating 1 and 1 on both sides. So then we get here x is equal to y by factorial 1 minus y square by factorial 2 plus y cube by factorial 3 minus dot dot 2. So this is your answer. Actually, question here is y is given as the subject of x, and now find x in the subject of y here. Okay, and now next question is after that, next question is here. See, you are given if y is equal to 3x plus 6x square plus 10x cube dot dot, then prove that x is equal to y by 3, and this is 1 into 4 by 3 square into factorial 2 into y square 1.4.7 by 3 cube factorial 3 into y cube dot 2 infinity. Okay, and see, we have to show this. Okay, prove that this, and this is here solution. See, y is equal to 3x we added with 1. Okay, 3x plus 6x square 10x cube. Okay, dot dot to that. Let us assume this is the series be 1 plus x whole to the power n. Here is x here, so we can use here x. Let us assume it is a. So now expand this, we can write here na, n into n minus 1 by factorial 2 into a square and dot 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 dot, and compare with that. So we can write na is equal to 3x, and this is number 1. Now n into n minus 1 by factorial 2 into a square, and that be 6x square. So now here na minus a, and 6 is 12x square. Okay, from 1 and 2 we get there. Na means 3x, so this is 3x, and this is 3x minus a, and 16x square. So we can write here x are cancelled. Na equal to 3x, and this is here na equal to 3x in 3x. Oh, this is here 12. This is 12. I have written 16, so that's why I'm constantly there. So okay, and this is 2 is cancelled. So now 3 is cancelled also. So 3x minus a equal to 4x. So a is equal to minus x here. So now n into a means minus x, and this is 3x. So then x are cancelled. So n equal to minus 3. So the sum of the series, that is 1 plus y, and this is equal to 1 plus a to the power n. 1 plus a means have x, okay, and n is minus 3. So now look here, and you can write here 1 plus minus x whole to the power and cube, and that is equal to 1 by 1 plus y. And now it will be a cube root 1 plus 1 minus x. So, and this is equal to 1 plus y to the power minus 1/3. So therefore 1 minus x is equal, we can write the expansion of that like 1 plus nx. This is 1/3 into y. After that, n into n minus 1 by factorial 2 into x square. After that, minus 1/3 minus 1/3 minus 1 minus 1/3 minus 2 by factorial 3 into y cube and dot 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 dot. See, on the both side 1 are cancelled. So then we get x is equal to, here is minus, so sign the change, y by 3. Changing the sign in alternate. Here is minus, so the minus are cancelled. Here is plus, we get here plus, so minus is changes, then we get here minus. If we take here y square by factorial 2, and now take the LCM 3, this is 3 square. Okay, after that, there is 1 into 2. Okay, see, this is here 1 into 4. Okay, got, I'm wrongly written here. So this is here 1 into 4. So if you take a LCM, this is 1 into 4, okay. This is 1 into 4 into y square. After that, it will be plus. This is factorial 3. And 3 cube. If we take LCM minus, okay, this is 1, and this is here 4, and this is here 7, and this is y cube. Okay, so it is your question to prove. And now next question, follow the next question. See, this is a very interesting question. Next question is that there is question you have to show. This is here prove that is that 1 plus 1 dot x by factorial 2 dot x square by factorial 3, and this is 3x cube by factorial 4. Okay, dot to infinity, and that will be is equal to e to the power x, this is x minus 1 by x, and this is whole by x actually. This is here 1 plus x. Okay, and JEE 89. Okay, now see, we can write easily. Actually, look that if we take one, then series is take some problem there. Okay. Now let us assume this is as a R. Okay. Now on the left hand side, let us assume this is R. That is 1 dot x by factorial 1. This is 2 dot x square by factorial 3. 3 dot x cube by factorial 4. Okay, then it can be find any term, but if we include one, so formation are not in order. Okay, now see here 1, 2, 3. So in place of that, we represent as n, as this is nth term. So here x will be 1, 2, 3. This is we can write here n. Factorial to factorial. If we take power b1, then here factorial 2. So is 1 is more always. So you can write here factorial n plus 1 if the power b in here. So in the discussion of infinite series and some of the point, there was a mention that if the in case of the nth term n or n in the new order car should be n can be eliminated, then problem will be so easy. Okay, now this is here okay, and this is here factorial n. And now we can write here n in place of n plus 1, and this is minus 1. So n plus 1 and x to the power n by n plus 1, and this is factorial n. Now x to the power n by factorial n plus 1. Now you can write here x to the power n by factorial n, and this is x to the power n by factorial n plus 1. Okay, now put here, now putting putting n equal to 1 comma 2 comma 3 dot dot. Okay, now this is t1 and we get here, and that is x to the power 1 by factorial 1 minus x to the power 1 by factorial 2. Okay, this is t2, x to the power 2 by factorial 2. Now x to the power 2 by factorial 3. Okay, and t3, and that is x cube by factorial 3, then x cube by factorial 4 there. Okay, and so on. Okay, then sum, if we sum, then we get as a r. This is as a r. Okay, and that will be like x by factorial 1, x square by factorial 2, x cube by factorial 3, like that. Okay, after that here x by factorial 2, x cube square by factorial 3, x cube by factorial 4. So there are some change, small change there. Okay, and for the e series, if we 1 we added, then we get e to the power x here. So 1 we added here, x by factorial 1. Okay, x square by factorial 2, like that. And again for that 1 by x, there is a, okay, this is minus 1. Okay, after that there 1 by x are written and multiplied by x, then we get the system. Okay, like that, x square cube by factorial 3, which is 4 by factorial 4. Okay, and now also this is e to the power x here and minus 1, and this is 1 by x. So in case of that, 1 we added 1 plus x by factorial 1 and x square by factorial 2 and dot dot this, and this is 2 times added, then subtract this. Okay, so here I can write also, so e to the power x minus 1. Okay, this is 1 by x, and this is e to the power x and minus of that, e to the power x minus x and minus 1. So right here, and then take LCM. Okay, so x into e to the power x and minus 1 here, and this is e to the power x minus x and plus 1. So okay. And this is your result for R, but the series is here 1 plus 1 something. So therefore the 1 plus R. So therefore the 1 plus R, and this is equal to 1 plus, okay, 1 plus x by x into e to the power x minus 1. X into e to the power x minus x minus e to the power x plus x plus 1, and take a LCM, then you get here x plus this. Okay, so x and x are cancelled, so we got the answer by x e to the power x, this is x minus 1 plus x and plus 1. This is your answer, and this is the answer. Okay, so very interesting question. So after that, this is the 2 more question here. See carefully, and more interesting question. This we have. Next problem, e to the power x by 1 minus x, and that is equal to a naught, a1x, a2x square, a3x cube, dot dot, an minus x to the power n minus 1 and an x to the power n dot dot to that. Then show that a suffix n minus a suffix n minus 1, this is 1 by factorial n. Solution, is e to the power x into this. Now expand e to the power x, x by factorial 1, x square by factorial 2, x cube by factorial 3, dot dot, x to n minus 1 by factorial n minus 1. You can write here 2 minus 2, x to n minus 1 by factorial n minus 1, x to n by factorial n is, after the expansion of this 1 plus x square, so x to the power n minus 2, x to the power n minus 1, x to the power n, and this is equal to a naught, a1x, a2x square, a suffix n minus 2 x to the power n minus 2, a suffix n minus 1 into x to the power n minus 1, a suffix n into x to the power n, plus dot 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 up to infinity. Okay, so equating the coefficient of h to the power n, equating the of h to the power n on both sides. Then on the left hand side, this is h to the power n is here an, and on the left hand side, see, if we start from here, this is here x to the power n, if we multiply by that, we will get here 1. Again, if we multiply by x to the power n minus 1 to this, we get here x to the power n, then factorial 1 by factorial n, factorial 1, sorry. And after that x to the n minus 2, here is x to the this is 2, so we get here 1 by factorial 2. Okay, and then after, like 1 into 1 by factorial, this is n, x into this is 1 by factorial n minus 1. Okay, this is 1, and equating the coefficient of x to the power n minus 1 on both sides. Then on the right hand side, we have a suffix n minus 1, and on the left hand side, see, this is the x to n minus 1. We multiply by 1, then we get here 1. Okay, this is here 1. After that, x to n minus 2 with this 1 by factorial 1. After that, x. Okay, Now see, comparing the question x where n minus 1. Okay, then if we 1 by this, then we get there 1 by factorial n minus 1. After that, we get this by this, okay. So 1 by factorial n minus 2. This is 2. So doing 2 minus 1, sorry, 1 minus 2. This is here 1 minus 2. Then n minus 1. So okay, these all are cancelled, so we have left here only 1 by factorial. Okay. Okay, say carefully. Okay, very good question. See carefully. Okay, this is the base problem for infinite series. Okay, and now another problem is that this is there. If 1 by a, 1 by b are the roots of the equation x square plus px plus q equal to 0. Okay, this is minus. Then show that then log e to the power x square plus px plus q equal to log q to the power c and a plus b within the bracket x and a square plus b square by 2 into x square and so on. Okay. So from that, see, here is the root of this equation and solution here. So 1 by a plus 1 by b is equal to p. So a plus b by ab is equal to p. Then after a plus b is equal to p into ab. Number 1. Now again product of two roots. And this is equal to, this is your c by a, that is c by a, that is q. Okay, from 2. So from 1 and 2. So now bring here log to the s, take up one q here, that is 1. This is p by q into x. This is 1 by q into x square. Okay. And this is log. Then after p by q from 1 and 2. So this is put the 1 by a. So a plus b. This is here p into 1 by q. So this is 1 plus p by q here is a plus b here into x. And 1 by q, this is 1 by q, ab into x square. And that is equal to q into 1 plus ax and 1 plus bx. Okay, and that is equal to log q to the power z 1 plus ax 1 plus bx. That is ax is aq by 2 by 1 Okay. Minus bx b square x square by 1. Sorry, wrong something. This is 2, this is 3 here. Okay, this is 2 bq so by 3 here. These are this a plus b into x, and now half a square plus b square x square 1 by 3 a cube b cube x cube dot this. Oh, the formula is wrongly. Okay. Okay, very good question. To see the carefully, students. Actually, these infinite series are now I'm posting for some queries given from the rugby, and that's why I make a video to see carefully. And this is the video only for the competitive exam like joint IIT and ISI exam, Indian Statistical Institute, and it is more useful for the high study. Okay, bye everybody.